Hello everyone, my name is Jennifer Richard. I'm a 5th grade science teacher over at Bamwell Elementary School. Today I will be going over a lab activity training with you called Mix It Up, Solution, or Mixtures. During today's presentation, I will be reviewing mixtures and solutions, as well as demonstrating a lab activity you can do with your students. During this lesson, students will learn to differentiate between mixtures and pure substances. Students are introduced to solutions, homogeneous mixtures, and heterogeneous mixtures. Students learn that solutions are special types of mixtures where one substance is dissolved in another substance. Before I have my students engage in any activities, I like to give them background knowledge and/or real-world scenarios related to the content. Here is an example of a scenario that I've given to my students. Howdy, scientists! I made a very interesting discovery today. Sometimes when I mix things together, I am able to pick them apart. For an example, I am able to separate the fruit, cereal, and nuts in my breakfast bowl. Other times when I mix things together, I can't even tell there are several things that are mixed together, like when I make cookie dough. Can you see the cookie dough ingredients separately in my picture? And lastly, something really weird happened to me the other day. Can you guess what? I mixed some salt into my water and it just disappeared. What's up with that? So now that our scholars are excited and curious, let's talk about mixtures and solutions. What I like to do is I like to start off with a review before I even go into the lab activity. So for instance, in this case, I would start off with reviewing things that are not mixtures. I would talk about what are pure substances, letting the student know that pure substances are made of only one type of matter. Thus, the composition is the same throughout. So, things that are not mixtures are also known as pure substances. At this point, your students are still curious about mixtures and solutions. They're going to want to know what happens when two or more substances are combined. This is when you show your students visuals. It's very important for you to have visual images or non-linguistic representations of mixtures and solutions so that you can meet the needs of all students, those students that are under the special population umbrella, 504, and your ESL students. For those scholars that are on the secondary levels, such as 4th and 5th grade, you're going to want to review with them that mixtures can be homogeneous and heterogeneous. In a heterogeneous mixture, you can see the different substances that have been combined. A heterogeneous substance is not mixed evenly. It is not the same throughout. You can see all of the different parts. And just make sure you show them some images so that they can see examples, as well as in the lab they will be able to have the hands-on activity to make the connection. Scholars will also have an opportunity to learn that homogeneous mixtures are uniform in appearance. Sometimes they are mixed so well you cannot tell that there is more than one substance in the mixture. Sometimes homogeneous mixtures are solutions. Now that we're on the topic of solutions, I'd like to address some common misconceptions. Students may struggle with understanding solutions. A solution is a special type of mixture that is formed when a substance dissolves in water or another liquid. The substance that dissolves in a liquid may be a solid or it can be another liquid. Sometimes all or just some of the physical properties of the ingredient of a solution may change. Students tend to think that substances such as milk or chocolate that are uniform in color and consistency are pure substances when they are actually mixtures. Students may also incorrectly believe that when a substance dissolves, it disappears. When a solute dissolves in a liquid solvent, the solid particles fill the spaces between the liquid particles. The small particles of matter that make up the solid are still present. However, they are so small that they are not visible. After you review the mixture and solutions concept with your scholars, have your scholars engage in a quick turn and talk activity prior to starting the lab activity. Remember, academic conversation is important. Before we go into the lab activity, I'd like to point out that I've provided you with lab procedures located underneath the hyperlinks. I've also provided you with the lab data sheet that your students will need to complete. The lab data sheet includes an area for documentation of data, reflection questions, and exit ticket questions. I've also provided you with a few examples of anchor charts that your students could use as resources. Now let's enter my lab. Welcome to my lab. I'm ready to get started. Are you? Here are a copy of the lab procedures and the lab data sheet that we'll be using for today's activity. The materials that you will need are sand, spoons, small rocks, paper clips, toothpicks and drink mix, glassware, sugar, and water. You'll also need some small strips of paper. Our procedure for this lab will be to fill 2 jars about halfway full of water. Okay. Next, we're going to put the marbles, paper clips, toothpicks, and bits of paper in one jar, and a spoonful of sugar in the other jar. So let's start off with our rocks. All right, now we need to stir both jars and observe what happens to the material in the water. I'm now stirring my sugar into my water. What do you think is going to happen? I'm gonna let that sit for a few minutes. Now over here, our mixture, I'm gonna stir it up. Now you're going to observe what is happening. Okay, compare the results in the 2 jars. One is a mixture and the other one is a solution. You're going to document your information on your lab data sheet. I've created the lab data sheet for you. Each station has the materials that we're going to be using in this lab. The question is it a mixture or a solution? You're going to document it here. Is it a mixture? If it is a mixture, how could you separate it? You're going to tell me how you're going to separate it. If it is a solution, what properties changed? Did anything change? And you're going to do this for each set of materials that you've used in this lab. Next, after you finish your data, you're going to come down to your reflection and you're going to answer a couple of questions. First question says, how are mixtures classified? And you're going to answer that in complete sentences. Next question on your lab data sheet is, what properties of matter can be used to separate the substances in a mixture? You're going to answer that in complete sentences. Finally, when you get to the end of your activity, there are going to be 2 exit ticket questions, and they are based on STAR questions. You can try other substances in water, such as sand, powdered milk, or powdered chocolate. So I'm going to go ahead and try one of those with you with the drink mix. You're going to pour halfway with your water. I'm going to open up the drink mix. And this is powdered just like the sugar. I'm going to pour it in. All right, now you see that it is sitting on the bottom of my glass jar. What's going to happen when I stir it? All right. Back over to this mixture. Now I want you to separate everything. All right. Was I able to pull apart my mixture? I still have toothpicks here. I still have tiny rocks, paper clips, and bits of pieces of paper. All right, go ahead and finish your lab sheet. Good luck. All right, educators, now that we've finished our mixed up mixture and solution lab activity, I have an extension activity that can be done after that lesson, or you can send it home for a home activity with the student. This activity is called, How Can You Separate a Mixture of Salt and Pepper? This activity is intended to help children learn to conduct and evaluate problem-solving procedures. There is no right answer, but some procedures may be more effective or efficient than others. For example, picking the pepper out is slow and tedious, but it works. Dissolving the salt in water and straining the solution through a cloth is more efficient. Encourage the scholars to think of and try as many ways as possible. This could introduce a discussion of the ways science and technology have been combined to find easier and more efficient ways to do things. So the materials that you're going to need in this activity is a plastic bag, 1.5 cup of salt, 1 teaspoon of pepper. So the procedure for this activity calls for mixing the salt and the pepper together in the bag. So let's do that right now. I'm going to pour the salt in. Now I'll pour the pepper. So your student's challenge will be to get the pepper out of the salt. How might they do that? So I'm going to mix it up before I try to separate it. So what you want your students to do is go ahead and document as many ideas they can come up with on how they're going to get each little tiny pepper particle separate from the salt. Then they're going to test their ideas and discuss their observations. And even if you assign this at home as a home activity, your students can get on the Google video chat when they come to class with you, when we're virtual, and you can have a discussion about how they separated their pepper from their salt. But what I'm going to do is I'm going to pour my salt and pepper onto my napkin here. I could also use a coffee filter, but I don't drink coffee, so I don't have that. All right, next what I want to do is I'm going to add some water, and if I add the water, I'm going to see what happens. This is something you probably don't want to tell your students. You want them to think about this first.